All right, guys, just in case you missed it in class, I wanted to make a quick video showing you guys how to put that average rate of change or average velocity function, how to get it programmed into your TI-Nspire. So I'm using the iPad app version here of the TI-Nspire CAS, so it's going to look a little bit different from your screen, but the functionality is the same, and I'll try to explain what I'm doing as I go through. So every problem that we do that asks you for average rate of change or average velocity uses the same formula. It's essentially the formula for slope. So what we're going to do is define that function in our calculator. So for me, I'm going to hit this little wrench icon right here, but what you guys would want to do on your calculator is hit the menu button, should be familiar with that, and then you're going to want to hit 1, 1. I'm doing this on my computer at the same time. 1 is actions. And then, I'm sorry, there we go. 1 is actions. I'm doing that same thing. And then 1 is define. So we're going to get to a screen here that looks like define, and we're going to call this function, I usually call it AV for average velocity just because that's a little bit easier to type in. So we're going to type AV, and then in parentheses here, guys, we're going to put the two variables that we define this function at. It's going to be A, comma, B. So again, I know my keyboard here looks different than yours, but hopefully you get the point here. All right, then we're going to need to hit our equals button for us, and for you guys, that is right under the control button, far on the left, about halfway down. So let's see, I can get to it here somehow, I think. There's an equals button here somewhere, Mr. Fontana. Let's find it. Okay, I'm not sure where I can get to that. There we go. AB is equal to. And now here's the function that we want to put in with our calculator. And for us, this is going to look just a little bit different here. You guys are going to do a stacked fraction. So you're going to hit Control Divide, and that's going to get you a piece that looks something like this. Okay, and I'm trying to do this on my computer here to make sure we're in the same spot as equal to. Control Divide. Gotcha. And then here you go. Our numerator then, everybody, is going to be the change in y that we've been talking about. So we're going to type this in as, here we go, f of b, that is our ending y value, and then minus f of a, that is our beginning y value. That's it for the numerator. That's the change in y. And then you can hit your down arrow or your right arrow. And down here in the denominator, we're doing the change in x, or whatever your independent variable happens to be. So for us, that's going to be b minus a in this setting here. That's it, guys. That's the formula for average rate of change or average velocity defined in terms of A and B, the variables where we start and end our intervals. So we want to go ahead and hit return now, and we should all see done over there on the right-hand side. If you don't see the word done, you're probably getting an error message, and that means that you messed something up. So I'd advise you to go back and make sure you've got everything typed in exactly the way I have it written right there. Now, the only thing stopping us from using this function right now is the fact that the way we defined the function, it is in reference to another function which we've called f. That's in our numerator. So this function is meaningless until we take the time to define what that function is. And this is important, guys. That f function is going to be different on every single problem that we do. So every time you do this, you're going to have to redefine what that function is. So for us right now, I'm going to go ahead and work out this a problem that should be in your notes already. I'm looking at our section 2.1 notes, part 2a, where it says find the average rate of change of a function, f of x equals x to the 1/2 on the interval from 0 to 9. So I need to type in that f of x function as x to the 1/2. So define. So you guys are going to hit menu and then 1, 1, and that'll get you back here to define. And we are going to type this function in now. Its name is going to be f of x. And really, you could use whatever variable you wanted here, guys. You could use t or whatever the problem was dealing with right here, but x is usually the easiest one. And now we type in the function unique to that problem. So for this one, it was going to be x raised to a power. Ooh, and I'm not sure if I know how to do that. Let's take a look. X, here we go, to a power of 1/2. Okay, that should work for me, and I'll hit enter, and there it is, and it's done. Okay, so now that we've defined our average velocity or average rate of change function, same thing, and then we've defined the function that's unique to this problem, f of x is equal to x to the 1/2, I should be able to answer this question now having the calculator do all the grunt work for me. So I want the calculator to tell me, all right, here we go, what is the average velocity of that function that we just defined on an interval from 0, comma, up to 9. All right, now since that AV came up as bold, that should happen on your calculator too, that means that the calculator knows what you're talking about. It has a definition for that AV function. So as soon as we hit return now, we should get the answer that we came up with in class in our notes, which I believe was 1/3. And sure enough, that's it, guys. That is the average rate of change, which is also the slope of your secant line on this function, x to the 1/2 power, on the interval from 0 to 9. While we're at it, let's go ahead and talk about how you would do a new problem now. The second example we did there was asking you for the average rate of change of g of x is equal to cosine of x on the interval from -pi/3 to 11pi/3. So let me say again, every time you go to do a new problem, you have to redefine f of x, which we did in this step right over here. So you don't have to erase anything. You can just kind of type over it. Menu 1 is going to get us to define. And once again, even though the problem I'm reading says g of x, we define the function in our calculator as f of x. So we've got to make sure we're typing it in as f of x each time, regardless of the way it's written in the problem. So f of x is equal to, and we're doing a trig function right here. This was just cosine of x. So we'll hit enter. And now f of x has been redefined. This definition, my dog's very excited about this, this definition replaces the f of x definition we had, 2 lines above here. So now, let's do it again, guys. We're going to go to f of x now, or excuse me, AV, all right, and now we want the calculator to compute the average velocity of this function on an interval now from -pi/3 to 11pi/3. So let's see, -pi divided by 3, that's my starting value, comma, and then we're going to end this thing at 11pi/3. And I'm pretty sure when we did this problem in class, we got an answer of 0. Let's see if that happens here as well. Yep, we got it. And if you remember, guys, average rate of change is the same thing as the slope of your secant line. So what happened in this problem is I was asking you guys to define a secant line by 2 peaks, if I'm not mistaken, on a cosine wave. And then when we drew the secant between them, that ended up being a horizontal line. Let's see if I can show you that one real quick. If I added a graph right here, I'm trying to reacclimate myself with this app here. F of x is equal to cosine of x. That shouldn't surprise us that it looks like this. And let's see if I can find those 2 points. If I did a trace and a graph trace, and how do you type this in? You guys could just use your keypad to type in -pi/3. I don't know that I can do that right here on this app. That's unfortunate. Graph trace, double tap trace the point. Double tap the trace point to enter an exact value. Let me try that. Okay, got it. Look what happens when you read. Okay, -pi divided by 3, enter. Okay, there's that. I take that back. That was not a peak. But okay, that's it. And then long press the trace point to create a persistent point. That's what I want to do here. So if I hold that for a second, okay, that locked in. And now let me do this again here, guys. If I trace this a little bit further to the right, okay, tap the trace to the left or to the right. Okay, and what happened? If we double tap that, I should be able to type in 11pi divided by 3. Okay, and there's that one, and I'll hold that guy down just a second. Okay, the persistent point, that's what they called that. I like that. And now this is much easier for me than it is for you guys. I can go ahead and just move my graph around a little bit with my finger and zoom in and zoom out, and unfortunately, your calculators are not touchscreen, so that's something you can't do. Now, what I think you guys can see from this graph here is that those 2 points have the exact same height. In fact, if I move those coordinates around, my y-coordinates at each of those points is 0.5. So I think you can visualize here, and I should be able to draw this, and I don't know if I can, but I think you guys can visualize here. That would be a horizontal tangent line that passes through those 2 points right there. And that is why, if I go back to my calculator page here, that your average rate of change would end up being 0. there because we have a horizontal tangent. All right, how do I get back? There we go, to 1.1. Okay, so that's just kind of a quick synopsis of how you do that. So just a reminder, every time you do a new problem, you guys are going to have to go back and redefine your f of x function. So you're going to have to go back to this line right here on each new problem. Okay, and again, you can just type over it. You don't have to go back and delete it, and then ask the calculator to do the average velocity or average rate of change on whatever interval it is that you guys need. Okay, hopefully that helps everybody. Good luck.